Let's see how we can draw the Lewis structure for carbonic acid. The chemical formula for carbonic acid is H2CO3. First, we should start with drawing the skeletal structure for this molecule. When we look at this, the structure of this molecule, actually it is the carbonate CO3 2 minus oxoanion connected with two H pluses. So in this oxoanion, in this carbonate ion, the carbon is the central atom. So we draw the skeletal structure by taking the carbon as the central atom, and there are three oxygens. So we connect these three oxygen and we draw a single bond between each carbon and oxygen, and then we connect these two H pluses to two oxygens. Then we calculate the total valence electrons for this molecule. There is only one carbon and carbon has 4 valence electrons. It will add 4 electrons. There are 3 oxygen. In one oxygen there are 6 valence electrons. So there are 3 oxygen. So 3 oxygens add 18 valence electrons. There are 2 hydrogens. One hydrogen has 1 valence electron. 2 hydrogens add 2 valence electrons. 4 plus 18 plus 2. The total gives us as 24 valence electrons in this molecule. Then we calculate how many electrons were taken for these single bonds. So let's count how many single bonds are included in this skeletal structure. 1, 2, 3, 4, 5. So there are 5 single bonds. Each single bond takes 2 electrons. So 2 by 5 is 10 electrons. So we subtract the 10 from 24. Now we have 14 valence electrons are remaining. Next, we'll complete the octets for these oxygens. So we add 2 electron pairs, 2 lone pair electrons to these oxygens which are connected to the hydrogen, and we add 3 lone pairs to this single oxygen. So altogether, if we count these or the electrons on these oxygen lone pairs, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So we subtract the 14 from the 14 which has left, and we do not have any remaining lone pairs. Are we done with the structure? No. Now we should count the octet or the electrons on this central atom. We always make an octet on the central atom. So when we count the electrons on this central atom, we received only 6 electrons. Each single bond counts 2 electrons. 1, 2, 3, 4, 5, 6. Carbon has only 6 electrons. So now we are trying to move. So the carbon has few electrons. Therefore, we need to convert one of those lone pair electrons on oxygen as a second bond to the carbon. We are making a double bond between this carbon and oxygen. So here is the final structure for this H2CO3 molecule. If we count the electrons around this central atom, now we'll get 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 electrons on the central atom. If you count the electrons around each of these atoms, they fulfill the octet on these atoms. Don't forget that hydrogen can have only 2 electrons. So each single bond fills those 2 electrons.